The last in the series is dependency inversion principle. Before I give you the definition for dependency inversion principle, let us have a brief idea about loose and tight couplings. When in tight couplings, when various components of the software depends on each other, then changing one component will require changes in other components which depend on that specific component. And thus, it becomes very difficult to implement changes in such software because changing in one place means changing so many other places as well, and then doing a lot of retesting each time. In loose coupling, the software components are loosely coupled. If a specific component changes, other parts of the software remain unchanged. So in order to achieve a loose coupling, dependency inversion principle says that various components of the software should not depend upon the concrete implementations. Rather, they should depend upon the abstract declarations. This will be clear when we look into the piece of the code. A bad example of dependency inversion principle and a good example of dependency inversion principle. So the basic concept in dependency inversion principle is that we want to invert the dependency of various software components from concrete implementation to the abstract implementation. Okay, now let us have a look at the code. So we have a bad example of dependency inversion principle. In this implementation, we have a class called MySQL database. This class communicates with the MySQL database for various operations. Say, for example, saving data to the database, and it has got a method called save data. Now, there is a service, user service. User service, in order to persist its users to the database, it will be instantiating MySQL database class object and calling the method on it. Fine, no problem so far. If one day there is a need to move from MySQL database to some other different database, and on one fine day there is a need to move from MySQL database to MongoDB implementation, what we will do? What changes we will do in our software? We will write a class which can communicate with the MongoDB. Say, for example, class MongoDB, and this has got a method called save data. No issues till this point. But because now we will not be using communication with MySQL database, so every service, not just user service, every other service in the entire software which is calling MySQL database object now need to instantiate another class object and call the method on that implementation. So this requires this one change from MySQL database to MongoDB will require change in almost every service. Why this is happening? Because every service class depends upon MySQL concrete implementation. Now let us look into another example, which is a good example of dependency inversion principle and how we are solving the problem of changing code when there is a change in the database implementation. Now let us see the correct implementation of the code as per the DIP principle. So instead of having direct implementation of a class and then referring to that concrete implementation class in the usage, here we declare an interface called database. There is one class called MySQL database communicating to MySQL DB that implements database and provide a definition for save data. Then there is another class which can communicate with MongoDB, implements the same interface database, and provide a definition for same data. In the usage section in a service class, this service class is now not referring to MySQL database or MongoDB database concrete implementation. Rather, it is referring to the database, the abstract definition for communicating with a database. At the runtime, now you will ask me which of these two class objects will be used by user service. At the runtime, if MySQL database object is available, this DB object will be MySQL database object. If MongoDB object is available, this DB object will be MongoDB object. So whenever there is a change at the runtime, we can decide whether to make MySQL database available or MongoDB available. This user service code is unaffected from these changes. Today we are using MySQL database implementation, keep using it. No problem. Tomorrow we switch to MongoDB, switch to it. User service is not going to at all get affected. So dependency is now inverted from concrete implementation to abstract definition.